So algebraites, let's see. Number one, we're going to solve equations. Number two, we're going to solve problems by writing equations. So we're going to do some application as well as just generic math. Now before we do that, there's a few properties we need to know. Again, we're going to quote these properties as we justify our answers. Okay, this first property is a duh one. What do you see in a mirror? I see myself. So this is called the identity property. Identity property simply says A is A, or 6 is 6. Next, here's one that we switch around, and it looks like the commutative property, but it's called something else because of the equal sign. It's called the symmetric property. Symmetric property. Symmetry just means things match up. Next up, this one is a familiar one. If A is B, if A equals B, and B equals C, then A equals C. So in other words, you just go over the B and connect to the C. That's called the transitive property. Like the transatlantic flight that goes over the Atlantic. The Transylvania means over the forests. All right, and this one here, if A is B, then B can substitute. Hey, look, there's the word right there, substitution property. Substitution property. Just, in other words, you can erase and replace. You can erase and replace. What I would like real quick with your partner, you're going to summarize these just with a few words. So, for example, substitute. What did I just say? Erase and replace. Okay? Erase and replace. That's what the substitution property. If A equals B or if A equals 10, I can just substitute in. Erase and replace. Please take a few moments to go ahead and find a summary up here for the other three. Notice this property right here. We start with a true statement, and notice all we've done is add C to both sides. So this is called the addition property. Clearly, for this one, if we subtract C on the left side, we have to subtract C on the right side. That's called the subtraction property. You know the other ones, but I'll go ahead and say it. So if we multiply C by C on one side, we must do it on the other. So this is the multiplication property. And lastly, we see if we divide by C on one side, we have to divide by C on the other. That's the division property. We could summarize all of these with one simple statement, and it's nothing new ever since you've been learning algebra. Your teachers always said, whatever you do to one side, do to the other. That's all pretty much we're going to put here. All right, so whatever we do to one side, we have to do to the other. And this applies to other things too. So take the square root of both sides, take the square of both sides, etc. So it goes on and on and on. All right, we're going to look at this one problem, and we're going to solve it two separate ways, just to show you that there are multiple ways to skin a cat. All right, so first off, I am just going to subtract 7 from both sides, or 6, excuse me. So what did I do? This is the subtraction property. Whoa. All right, so 64 there. Now, a lot of us probably said this. Let's go ahead and distribute. But it's actually here that we could have done something different. So that's the distributive property. I'm going to abbreviate distprop. And now I'm going to add 6 to both sides here to bring me back to 70. Hashtag back where I started. Addition property. And my last step, I'm going to divide. Notice I'm not even going to show the division. I'm just going to do the division. 35. And this is the division property. Box or circle your answer. And we'll do a quick check at the end in a moment. All right, now let's look at this and just show you that there's an alternate way to do it. So watch this. I'm going to subtract 6 from both sides. Again, so 2y. Don't forget my parentheses. Minus 3 equals 64. Now watch the magic here. And I'm going to show you it, although I hadn't been doing it before. I'm going to get rid of this times 2. Instead of distributing it, I'm just going to get rid of it. So notice I don't have to distribute anything. It just reduces. So now I bring down the y minus 3, and over here I have 32. Now I'm going to add 3 to both sides to get my 35. And there we go. What steps did I do? Again, I did the a subtraction property by subtracting 6 from both sides. Next, I use the division property, get rid of that 2. And lastly, I did the addition property to get rid of the negative 3. After this problem here, and it says 2 brothers are saving money to buy tickets to a concert. It does not matter that they're buying tickets. That's not important. It doesn't even matter that they're brothers. However, what is important is that 2 are saving. 2 are saving because the 2 tells you the number of things and the saving actually tells you the operation. Okay. They're combined. There again, combined is part of the savings. Combined there would be plus is 55. So I actually don't know what to call them yet. So maybe I'll call brother 1 A and brother 2 B. I don't know at this point. So I'll start by saying A is brother 1. Hey, bro. Was that Kanye West? At the MTV Music Award or something? I don't know. There was something going on. He was just like, dude, I can't believe, bro. Hey, bro. Hey, bro. Like the whole time, like, are you a surfer or something? All right, so we've got 2 brothers. They're buying tickets. So quickly, we know this. Some people might jump and say, well, when you add them together, combined is 55. But let's actually, we're going to use that as a base, but I'll come back to that in a second here. One brother has $15 more than. $15 more than. So we actually don't know which brother has more money. So we're just going to choose one. I'm going to choose the top. Why? Only because it says one brother, and I labeled this brother 1. Okay, that's just a coincidence. You could have done the other one. All right, so here, if I take brother 2 amount of money and add 15 to it, that is how much brother 1 has. So notice here, I can actually substitute. I'm going to erase the A and replace it with B plus 15. So when we add the 2 brothers' amounts together, we have this expression. Now notice the A plus B equals 55 was my original idea. But I reinterpreted it after I got a little bit more information. Why? Because if you have 2 variables, you need 2 equations to solve it. So I was able to substitute in, so now I only have 1 variable that shows up twice, and now I can combine like terms. So now I get 2b plus 15 equals 55. You could have subtracted the 15 at this stage and jumped to this step here, 40. And then b is 20. Now let's go back and interpret. How much has each saved? So it looks like brother 1 saved $35 and brother 2 saved $20. Now real quick, I'm committing to this as an answer, so when you commit to it, put a ring around it. And, or box. How do we know we're right? Before I let you go on this one here, we need to define consecutive numbers. Consecutive numbers. Consecutive just means in order. Con means with, and secu means sequence. So this just means with an order. So consecutive numbers would be something like this: 21, 22, 23. Those are consecutive numbers. Consecutive letters, X, Y, Z, those are consecutive letters. If I say consecutive odd numbers, I could say 3, 5, 7, just counting by odds. Okay, so how do I write 3 consecutive numbers? Well, if I call X the first number, what's the next number? How much more is it than X?
+1.
It's only one more, because look, 21, add 1 to get to 22. So how much do I add to X to get to the third number?
2.
I have to add another 1. So if you're doing consecutive numbers like this, you just start with a number, you add 1 to that, you add 2 to that. If you're going for a fourth one, you add 3, add 4, add 5, etc. And it says here, the 3 numbers sum to 126. Take a few moments to do this on your own. Now when we solve this, we get 3x plus 3 equals 126. Now subtract 123, and x is 41. That's not your answer. Your answer now, you have to add, show the next 2, 41, 42, and 43 right there. Now, I noticed some other people who, rather than go to algebra like this, went straight to kind of a guess and check method. And that would work because what we could do is just take 126. We know we have 3 numbers. So if you take 126 and divide it by 3, you get a number, 42. Now, that number, because it's the average, it's going to be in the middle. So go up 1 and go down 1. Okay? However, that might not always work, but at least 42 tells you where you're going to look. I could do 42, 43, 44, just plug that in my calculator. Oh, that's too high, so let me go lower. I can go 40, 41, 42. Oh, that's too low. So 41, 42, 43. So at least this will give me a place for checking and guessing. All right, the last type of problem that we're going to look at, well, actually 2 more, sorry, is that we want to look at what's called no solution, a situation that doesn't make sense, or a situation that does make sense, but not helpful. So let's just quickly define no solution versus identity. No solution is nonsense. Nonsense. And some of you say, all of math is nonsense. But the most silly nonsense would be something like this. 10 equals 7. And you say, that's not true. 10 does not equal 7. So this would be a nonsensical no solution, nothing ever works. Another one over here is called an identity, but it's not helpful. Not helpful. 7 equals 7. I know 7 is 7. That doesn't help me. I don't want to know what 7 is. I know. I want to know what x is, because x means unknown, right? So sometimes you're going to solve and you're going to get a value, x. X is some number. Great. I figured out what that is. All right, on ejemplo 3, what we want to do is start solving, and it looks like I'm just going to attack by distributing, okay? I could have probably divided and stuff, but it wouldn't be too helpful. So when I do that, I get 6x plus 6 equals 10 plus 6x. Now I'm going to show this step here just to show you what's going on, but usually I haven't been showing this step. I'm going to subtract 6x from this side, which means I also do on this side. And quickly we see, ka-chow, ka-chow. We have annihilationism there, and 6 equals 10, and you say, no it doesn't. So the answer here is no solution. In other words, so that's my answer. This is the thing that I circle. This tells me that there is no solution. This needs to be interpreted to no solution. No solution is your actual, what you commit to there. 6 equals 10 is nonsense. Take a gander at this one. So we saw that there was no solution because it was nonsense. So now let's see what happens on this. Here, if we distribute there, y también aquí. So then 3 y plus 9 más 5y igual 8y más 4 más 5. And now we're going to combine like terms. Sometimes I like to circle or connect the like terms just so that I'm paying attention and keeping track of things. So if you find that this is a helpful thing, word to your grandmother. 8y plus 9 equals 8y plus 9. Now at this point, we can actually stop because I see what's on the left side is exactly the same as what's on the right side. Now a lot of people don't necessarily stop here. They keep going and say, oh, let me collect my variables by subtracting 8y from both sides. And when you do, you end up with 9 equals 9. Now, it doesn't matter at which stage. The most important part is not what numbers. It's the fact that it's exactly the same. It could be letters, it could be numbers, it could be anything. As long as it's exactly the same, we now interpret this to say infinite solutions or infinitely many solutions, also known as identity. Also known as identity. Or another way to interpret is infinitely many solutions. So I'll go ahead and write that down. Infinite solutions. I tend to abbreviate solutions like this, SOL''N. All right, and the last thing we're going to look at is something called solve for something. Generally speaking, when we solve for something, we get a number. X equals 12, Y equals 13. But ultimately, the skills in algebra can help us to rewrite formulas when we know things. So for example, area formula. If I know the length and the width of a particular, so I'll not use that example, but let's say I have the area of a rectangle, base times height. You don't have to write this down. If I know the base and I know the height, all I do is plug it in and simplify and I'm done. However, what if I know the area, 15, and I don't know the base? Well, one way to do it is for us to substitute like this, and then we can rewrite. We divide by 5, and we end up getting 3 equals b. However, what I could have done was do the division first. So to find out that the base is the area divided by the height. So now I could just plug in straight right there, and then not have to do inverses, not have to move anything to another side. So that's called solve for. So that's a skill that we definitely need. So how do I solve for W here? So this gets a little bit complicated. But let's walk through this problem here. I'm going to write A over here. And notice what I did here, and that should be an H plus LH. And I'm going to write my L kind of like a cursive, thank you. Just so it doesn't confuse it with a 1 or something. So what did I do? I used the distributive property to factor out the W. So now I have a W here. Now, how do I get W by itself? Well, I need to get rid of this LH. So I'm going to subtract LH from both sides. And some of us might say, hey, wait a minute. You can't subtract LH from A. And you're kind of right. What you really mean to say is that it doesn't change it. You can't subtract it because I can't rewrite it to something simple. What you really mean to say is you can subtract it, it just doesn't look simplified. So there you go. That's the subtracted there. Like so. All right, now the last thing I need to do is get W by itself by dividing by L plus H. So divide the whole thing by L plus H. So here's what my final answer is. A minus LH divided by L plus H is equal to W. Now that might not seem helpful. Maybe you're just saying, oh, that's a lot of work, didn't get me anywhere. Well, what it got me was W by itself. So if I knew A, L, and H, I could just substitute in. Pretty straightforward. So this one was a quick, complicated problem that we did, But I want you to practice now the next one over there. So go ahead and practice. How do you get y by itself here?